Hey everybody, so if you look, I have up here two equations. I know they're equations because we have equal signs now. And the directions for equations are always to solve. Solve means to isolate the variable. Now the important thing is to understand what type of equation is this. These are both linear equations because if you look, the variable x is understood to have an exponent of 1. So we would say this equation is degree 1, this equation is degree 1, which means when we're done solving, we'll only get one solution, one answer. All right, to solve the linear equation 4x minus 5 equals 27, every equation has a left side and right side. And the way I note that is I draw a wall. And the wall is where the equals is. So I know this is the left side and this is the right side. And your goal is to get the variable isolated on the left side. The left side I should see an x, the right side I should see a number. So I'm looking here. X is not by itself. It's 4x minus 5. There's a 4 connected to the x by multiplication. There's a minus 5 connected by subtraction. To move the numbers, you have to be in a specific order. We're going backwards of, please excuse my dear Aunt Sally. When we're solving an equation, we move add and subtract first. It's kind of like undressing the letter X. Think about when you go home and undress. What do you take off first? Your shirt or your shoes? You take off the clothes that's furthest away. So you take your shoes off, then you take off your shirt, your pants, and then put on your PJs, right? Same thing with solving an equation. This number is further away from the x than this one because when you're connected by multiplication, you're butt up against each other. So to move it, subtract 5, we do the inverse operation. We add 5. And because an equation is a balance, think of it like a seesaw. What you do to the left, you got to do to the right to keep it balanced. We're going to add 5 here. Subtract 5 and add 5 makes 0. So we just cancel them out because 4x plus 0 would be 4x. 27 plus 5 is 32. Are we done solving? No. X is not isolated. So now we have to move the 4. 4 is connected by multiplying. The opposite operation of multiplying is to divide, and that's what the fraction bar is. So the opposite of multiplying by 4 is dividing by 4. Now I know what you're saying, but Miss Black, up here when you did the opposite, you changed the signs. But people, the opposite of add is subtract. By saying that, the signs are always different. The opposite of multiply is divide. Those signs are not different. When we divide, 4 divided by 4 makes 1, but we don't have to write 1x. We understand the coefficient's 1, so we just write x. And on the right side, 32 divided by 4 is 8. We have our variable isolated. We have our solution. Now, very important. Once you solve, you should always check your solution. The way you check your solution is you go back to the original equation. So you rewrite the original equation, but now you're going to replace, substitute. You're going to replace that x with the number you found, 8. So this is 4. We're replacing x with 8. They're side by side. They're connected by multiplication. So we put parentheses. Minus 5 equals 27. When you check an equation in math, it's like checking your checkbook. You add up all your credits, you add up all your debits, and you hope and pray that it balances. So when you check, you get a number on the left, and you're hoping that it's going to equal the number on the right. When you check, you do not move terms. We do not check like that. Think about your bank book. Can you just take your debits and put them in your credit column? No. So if you look, there's nothing to do on the right side. It equals 27. We're going to work the left side. 4 times 8 is 32. 32 minus 5 is 27. Hey, 27 equals 27. That checks it balanced, which tells me I have the right answer. If you're solving a linear equation and your check does not balance, that tells you you made a boo-boo in the solving process. All right, let's try one more. Here's our linear equation. Negative 2x plus 1 equals negative 18. I'm going to draw my wall. And on the left side, here's my x. I have to move a -2 and I have to move a +1. I move add and subtract first. So to move and add 1, I subtract 1. +1 and -1 are additive inverse. They will make 0. So this is just -2x on the left side. -18 and -1 are both negative, so we would add. They're alike. This would give us -19. The -2 is connected to x by multiplication, so the opposite of multiplying by -2 would be to divide by -2. A negative divided by a negative makes a positive. 2 divided by 2 is 1. We don't have to write +1x, we just write x. On the right side, a negative divided by a negative is a positive. Now, you could write this answer 2 ways. Does 19 divide by 2 and make a whole number? No, it does not. So you could leave it as an improper fraction, or you can convert it to the decimal. If you had $19 and you divided it among 2 children, they would each get $9.50. What you do not do in algebra is change it to a mixed number. Do not write the answer as 9.5. In higher math, we do not work with mixed numbers. So you either want your answer to be a fraction, and impropers are okay, or a decimal, a terminating decimal. And then you would check. It wouldn't matter which one of these values you checked. You would just use the number you prefer, which notation is easier to work with. Okay, see you in the next module.